Okay, so this illustration is going to be for what I call, again, scenario number 3, which I refer to as the proportion scenario. And I'm going to do exercise number 16, and this is in, again, your textbook. And here's the problem. It says Miss Maria Wilson is considering running for mayor of the town of Bureau Gulch, Montana. It says before completing the petition, she decides to conduct a survey of voters. The sample size here is going to be 400, and out of that 400, it revealed that 300 would support her in her election. So, to break it down, Part A says estimate the value of the population proportion. Well, remember, your book uses pi, I like to use p, but the idea here will be to estimate a value of a population proportion, you need to get a sample proportion. And that formula is basically by taking x over n. Our characteristic of interest here is those who support her in her election, and that was 300. And then the sample size was 400. So if you take 300 divided by 400, you would get 75%, or I like to put it in decimals, 0.75. So the idea is, guys, that's going to be our value we're going to be using in our equation. So P bar, and I like to refer to this again as P bar because it's like a sample P bar is similar to X bar idea. Now, so that's part A. Part B says develop a 99% confidence interval for the population proportion. So now again, we're back to our Z value. Now over here I have a little more room. I'm going to write this out. And our formula, if you recall, our formula for a proportion is going to be P plus or minus your Z value multiplied by P times 1 minus P over N. Now, in the proportion problems, you're basically going to be using P bar, like your sample P bar, for all of these calculations. So this value right here, this 0.75, we're essentially going to be using as our planning value. So if you look at the formula, we know everything except the Z, and the Z is always determined based on the confidence. So if the confidence interval is 99%, and then if you go back to one of my previous, I think it's illustration number 2, I show you how to look this up in your Z table. I'll do it again right here real quick. Just remember 0.99 in the middle, divide it in half, you get 0.495 and 0.495 on each half. I know, I'm sorry, I got kind of scribbled there. You look up 0.495, you'd get a value that's right around 2.58 approximately for your Z-score. And I believe if you look this up in the solution, they use something else. I believe it's like 2.56 or it's like 2.576, which they're using computer software to do that. I don't expect you to do that, but 2.58 is definitely reasonable. So then what you basically then do is kind of write it down here, is to do the interval, just plug it in. So you're going to have 0.75 plus or minus your Z value multiplied by 0.75 times 1 minus 0.75 all the way over your sample size, which is 400. You got to hit the square root, multiply all that out, and then what you end up getting in terms of your interval, once you do the calculations, is you get it's about 0.694 all the way up to about a 0.806 as your estimate of support in terms of where people fall. But that would be the number you're going to come up with on your interval. I like to keep everything in decimals when I deal with proportions, simply because proportions are percents. But that's how you would do a problem with the proportion. Now, remember, this was 99%. They could have said 90% or 95%. The only thing that would change would be your Z value. But please note, this is a new formula, or a different formula than the sigma known and the sigma unknown scenario. But the nice thing is you are back to the Z value.